Hey guys, welcome back to my video series on solving LeetCode problems. This video's problem is 36 valid Sudoku. So we need to check if a Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3x3 subboxes must contain the digits 1 to 9 without repetition. Note the Sudoku board partially filled could be valid but is not necessarily solvable. Only the filled cells need to be validated. So we need to do this. We need to look at the board and it's rows. It's just lists. Each list is rows and then we have a big list of columns. So this is a bit of a pain. Something to do actually. Make directory 36 valid Sudoku. Code 36 valid Sudoku. So I think that this is not like a big deal of a problem. We just need to be patient with the solution. So we need to return true, for instance, and we do solution is valid Sudoku, and let me just copy an input board. So now we do for row in range 9, because we have 10 rows, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, we have 9 rows. Yeah, for row in range 9, then row index. Actually, we can do for row in board at this moment because we get the row. And now I'm just going to check if interesting characters relevant chars equals x for x in row if x is different than the dots. So I will just check if we have repeated characters. So if set of relevant characters, if the length of the set of relevant characters is equal to the length of relevant characters is different, then it means we found a row that is actually has a repeated character. So if we have a 3 here, then while we're iterating, we create a set which will be 5, 3, 7, and the length will be 3. But the length of the non-dot characters will be 4. So that is different. And yeah, that's it. That's it for the rows. And now for column. So for call index in range 9. So for row index. Now we need to do relevant characters equals board of x called index for x in range 9. Let's just call chars, and then we do relevant chars just to make it readable, and for x and call chars if x different than that, and then we do the same thing. That's it for the rows and columns. I'm just gonna run this and see if it fails. Okay, true. So it's good. And now we need to do for the these things, like these blocks are free. So for, let's see, for row start and row end in 0 and 3, 4 and 3, 0 and 3, 3 and 7, 7 and 9, yes, no, 6 and 9. And same thing for column start. Not row but column. So now we need to get this, this, and this. So all chars equals, that's a list. So for row index in range, row start and row end, buttons, row end, and same thing for call index, call start and call end, all chars, let's just call it current char, equals all chars of row index and call index, and if current char is different than a dot, we just append all chars, append the current char. Good, and now we do the same thing. I just call it relevant chars just to keep the same thing. Wait. Current char equals not all chars, but board. Okay, so let's run this. Return true. So let me put some breakpoints here, here, and there. So if we run this, okay, return true, means it worked. Board that fails, let me put a board that fails. Fails, okay, good. Submit. Okay, it worked. Well, the time and memory were not so good, but let's just submit again. See if it goes up from 25 and 38. 72, 38. I think this is the logic that we're going for. Short, simple, 162, solution using hash maps. Hash maps? Yeah, maybe there could be some stuff that could be done better. So for J, cross import big location. I don't know, it feels like people did some interesting things. I think I had a good result, and maybe the solutions are not so different. The descriptions, division into 3x3 blocks, convert matrix 3x3 to 1x9. I don't know, maybe I could do better. Hope you guys enjoyed it.